the same that you've seen in Algebra 1. However, I'm sure a lot of you have forgotten some of the steps in factoring, so let's talk about factoring this week. Steps to factoring. These guidelines are an intermediate algebra level of understanding factoring. Now, when you get into higher math, there are more factoring rules that you will need, but as of right now, these are most of them. Step number one, you always want to factor out the greatest common factor. Okay, so if there's something common to all of the terms, you want to factor it out. So basically what you're doing is you're just dividing out what is in common. So for example, if I had, let's say I gave you something like 2x, let me see here, I need to move my marker. I want to make it red here. Okay, so let's say I gave you something like x. Oops, my marker is being a little wonky there. Plus 4y. Well, what's in common to both? Well, there's a 2 in common. There's the variable's not in common, so what I would do is I'd factor out a 2. Well, how do you factor out a 2? Basically, what you're doing is you're just dividing each term by 2. So what am I left with here? 2x over 2, that gives me x plus, and then if I divide the 4 and the 2, I end up with 2y here. This is factored. Now, when you factor something, when you pull out the greatest common factor, if you multiply through, so I have 2 times x plus 2y. If I use distributive property, I better get what I started with. So 2 times x is 2x, plus 2 times 2y is 4y. Oh, that's exactly what I started with. And you need to end up with what you start with. Factoring doesn't change the polynomial. All it does is it simplifies it down for us. Okay, so make sure, you can always check yourself to see if you did it right. Now in this problem here, I look at it, I've got 8xy, I've got 4xy squared. Well, the greatest common factor is 4xy. So if I factor that out, so if I divide that out of here, 4xy and a 4xy, I'm left with 2, because 8 divided by 4 is 2. The x's are gone and the y's are gone. So all I'm left with is 2 here. Plus, here the 4's cross out, the x's cross out, one of the y's crosses out. So I'm just left with y. Now, if I multiply back through here, 4xy times 2, that's 8xy, plus 4xy times y is 4xy squared. I get the same thing I started with. So when you're factoring something and you're pulling out the greatest common factor, remember you're going to end up with the same thing if you use distributive property. Here, I'm going to factor out a 9m squared, because that's in common to everything. What's left here is an m minus, well, if everything crosses off, you have to put a 1 there. Why? Well, guess what? If I multiply through here, if you didn't have a 1 there, you would not end up with 9m to the third minus 9m squared. So if you factor something out and it's exactly the same term, you've got to put a 1 there. Distributive property to go backwards, it'll work. So step 1, anytime you're factoring, always factor out the greatest common factor. Okay, that's always step 1. Then you look at the number of terms. So if there's only 2 terms, then it could be the difference of 2 squares. Okay, they say the sum of 2 squares right here, but there's no such thing as the sum of 2 squares, so we just cross that off. There's no such thing there. So we have the difference of 2 squares, we have the difference of 2 cubes, and we also have the sum of 2 cubes. So yes, there is a sum of 2 cubes. And it's just basically patterns. Let me give you an example of a squared minus b squared. If I had, let's say I had x squared minus 16. This is a perfect square. This is a perfect square. It will always factor down to x minus, so you just take the square root of both terms, x minus 4, and then x plus 4. That is how it factors. If you don't believe me, multiply this through. Use FOIL. You will get the same thing. Let me use FOIL here just to prove to you that it works. So if you multiply x times x, you get x squared. X times 4, that gives me 4x. Negative 4 times x, minus 4x. And then negative 4 times 14 is negative 16. Well, look what happens to the middle terms. They cross off. So I end up with x squared minus 16. It does work. That is the difference of 2 squares. And that is how you factor it. Now, if you have the difference of cubes, it becomes, if you have a cubed minus b cubed, it becomes a minus b. and then a squared plus ab plus b squared. And I'll just work one of those out down here. So here, difference of 2 squares. So this is a perfect square, minus sign in between. So that gives me 3x minus 1, 3x plus 1. If I factor here, this is a perfect square. So that gives me 2n minus 7, 2n plus 7. Okay, so that's how you factor difference of 2 squares. Now, we have the sum of 2 cubes and the difference of 2 cubes. The formula is exactly the same, except right here and right here. Okay, you have, if it's a difference of cubes, you have a minus to start with, and then a plus here. And if it is a then it's a plus here and then a minus here. That's the only difference. Okay, so here I have the sum of 2 cubes. What is the cube of x cubed? That's just x. What is the cube of 125? That's 5. So if I was going to break this down, this is going, and I just usually, because this is my a value and my b value, so this is going to be x plus 5, and then my a term squared, so that's going to be x squared minus a, so my a value, b value, so that's 5x, plus my b squared, so that's 5 squared, which is 25. So that's a sum of cubes. Here, a cubed, so that would be a, 64 would just be 4. So now, my marker is really being a little wonky today. I'm not sure why. Let me flip this out and put it over here, see if that changes. Okay, so now if I was going to do this problem, let's see where my marker is now. Uh-oh, I don't even see my marker. Something's, that's my mouse. So let's see if I get my marker here. Okay. So now I have a plus, so that's going to be, it's going to be a plus 4, and then this term squared, so a squared, minus these two terms multiplied together. So that gives me 4a plus this term squared, so 16. Now if it's a difference of cubes, basically the same thing. This is x and this is 4 here. So it's just going to be x minus 4, and then x squared plus 4x plus 16. So that's the only difference when it's a difference or a sum. So make sure you know these ways to factor. All right. So if it has 2 terms, that's what you're looking for. If it has 3 terms, then it goes back to factoring trinomials. Okay. A trinomial factors, if the number in front of the x squared term or b squared or whatever squared it is 1, then it's super easy. You just look at this number and you ask yourself, what 2 numbers multiply to give me this number, and add up to the middle. Well, 7 times 1 is 7. 7 plus 1 is 8. Oops. Is equal to 8. So 7 and 1 are my 2 numbers. So this is going to factor down to b plus 7, b plus 1. Now, I could have had it b plus 1, b plus 7. It makes no difference. Another one with the 1 in front. So what 2 numbers multiply to give me 10? That add up to negative 11. Well, negative 10 times negative 1 is positive 10. Negative 10 plus negative 1 is negative 11. Oh, sweet. So I've got n minus 10, n minus 1. That is how it factors down. Now, if there's a number in front of the m squared, it's not as easy. I teach the cheater method. The cheater method says that, I'm going to take, I'll do this one first. You're going to take the 3k in both blocks, first blanks. Now we know that can't be true, because if you did FOIL, this would give you 9k squared for the first term. Well, we know the first term is 3k squared, so that doesn't work. So whatever we cheat with, we have to divide out at the very end. Okay, so I just put that over here. I'm going to divide out of 3. Okay, then my next step, I multiply the 2 outer terms together. 21. 3 times 7 is 21. Then it's basically like up here. What 2 numbers multiply to give me 21? adds up to negative 10. Well, let's try negative 7 times negative 3. Negative 7 times negative 3 is 21. Negative 7 times negative 7 plus negative 3 is negative 10. Awesome. So I just put that in there. Now, as I said, I cheated with a 3, so I have to divide a 3 out of one of the parentheses. Well, 3 doesn't divide into 7 evenly, so I'm going to divide it out of this parenthesis. So my answer is going to be 3k minus 7 times, and then I divide the 3 out of both of these terms. That's going to be k minus 1. Done. Factored. All right, let's try this one. Same process. So I'm going to cheat with a 7. So I'm going to divide a 7 out at the very end. So I'm just going to write that over to the side. So I've got 7m here, got 7m here. I'm going to multiply the outer terms together. 7 times negative 1 is what two numbers multiply to give me negative 7, but add up to 6? Well, how about 7 times negative 1? 7 times negative 1 is negative 7. 7 plus negative 1 is positive 6. Awesome. So I'm going to put a 7 here. I'm going to put a negative 1 here. Guess what? 7 doesn't divide into 1 evenly, so I'm going to divide this parenthesis by 7. So that gives me m plus 1, 7m minus 1. All right, so we talked about factoring. First step, factor out the greatest common factor. Second, you look for two terms. If there's two terms, then we use difference of two squares or difference of cubes. If there's three terms, then we factor like a normal polynomial, or if there's a number in front, we use what is called the cheater method. What happens if there's four terms? Oh no, so now we talked about two terms, we talked about three terms, now we're talking about four terms. When you have four terms, we usually use something that's called grouping. We take two of the terms and we just put parentheses around the first two terms. Oops, let me turn my marker on here. So I put parentheses around the first two terms. Usually if there's a minus in front of here, I'll make it a plus and make that negative 4x. Put parentheses around here. Then our second step is we factor out the greatest common factor in each parenthesis. So here I'd have x squared, so I'm going to pull an x squared out. I'm left with x plus 3. Here I'd pull out a negative 4, so that would give me x. Now if these are the same, grouping works. And then what we do is we factor out an x plus 3 because it's the same in both terms. So I factor it out and I'm left with x squared minus 4. And then it's like, okay, can I factor this down any farther? Well, that's a different two squares. So x plus 2x minus 2. So this is the factored form of this thing here using what is called grouping. Let's try another one. All right. So in this problem here, I'm going to use grouping. So I'm going to change this minus sign and make that plus. I can change this one too. Doesn't matter. So I'm going to put my parentheses around here. So I've got x to the third plus negative 2x squared plus negative 9x plus 18. Now I'm going to factor out the greatest common factor. So in this one, it's x squared. And what's left over? I've got an x plus negative 2 or minus 2. It doesn't really matter how you put it. Plus, and then I'm going to factor on negative 9 here. So that gives me x plus negative 2. Now remember, we could multiply through and we should get the same thing. Now this is exactly the same. So I'm going to factor it out. So if I factor out an x minus 2 or x plus negative 2, what's left over? X squared minus 9. Well, guess what? X squared minus 9 is a different two squares, so I can factor that down. Whoops. I can factor that down to x minus 3, x plus 3. So this is the whole thing factored out. That is called factoring by grouping. So what we did this week is we started with factoring out the greatest common factor. Then we went to two terms. Okay, so if a polynomial has two terms, then we use difference of squares or difference of cubes or sum of cubes. Then we went to three terms, and then we went to four terms. So that's all the different types of factoring you should be able to do this week. All right, hope to see everybody on Monday morning. You guys have a great week.